Hello dear learners, welcome to the channel Pen and Paper Chemistry. First of all, I would like to thank you all from the bottom of my heart for spreading a word about the channel amongst your friends and classmates and helping to spread this knowledge around. And then let's get started with the lesson for the day. This is video number 3 on the topic Grignard's reagent. We have already dealt with quite a few properties of Grignard's reagent. In this last video on the series, we shall be talking about the preparation and some remaining properties of Grignard's reagent. But before we do that, please make sure that you have your pen and paper handy so that you can practice, not you, we can practice the reactions together. We have already spoken about some of the nucleophilic addition reactions in the case of carbonyl compounds in our earlier video. Continuing with the same, we are now going to talk about the reaction of Grignard's reagent with acid chlorides. So let's get started with my favorite representation of the Grignard's reagent, RMGX. Acid chloride. Let's spread it out. CH3 C double bond O Cl. And as you can very clearly see, there's a carbonyl group. So get going, convert, transfer the electrons, negative, positive, negative, positive. If you've not watched video number 1, 2, please watch those videos. You will be able to understand what we are doing now in a much easier and simpler manner. Go ahead, add the negative to the positive, positive to the negative. So what we have here is oxygen says, come magnesium, I have some electrons for you. And the alkyl group goes and attacks the carbon of the C double bond O. So what do we have? Let's form the product over here. CH3 C Cl O MgX, and there goes our R. What do you know about the nature of Cl? It's highly possessive about its electrons. So it tries to take away the electrons. Who comes to the rescue of carbon to fulfill its tetravalency? Yes, of course, it's a long-time friend, oxygen, which has the lone pair of electrons on it. So with the result, we have our product here, CH3Cr double bond O, and then of course MgX and Cl. Isn't that really simple? So that means we get a ketone as our product. Question for you. You have to now complete the reaction of CH3MgBr with, okay, let me keep it simple only for you, CH3 C double bond O Cl. Form the products, try the reaction yourself. You will love the confidence in yourself. You will want to do more and more of organic chemistry after doing this. I'm actually waiting for you to write the reaction. You're waiting for me, I'm waiting for you. No, it's not happening unless you write it. Okay, you paused the video and you did it. Okay, let me give you the answer then. So CH3C double bond O CH3 plus MgBrCl. Pretty simple, right? So what happened over here is the Cl of the acid chloride was replaced by the alkyl group of the Grignard's reagent. As simple as that. Correct? We now have the next reaction. Grignard's reagent with carbon dioxide. Let's expand the wings of the carbon dioxide. RMgX plus O double bond C double bond O. Now overall it's a non-polar molecule, right, because of its linear structure, but each of its bonds individually is polar. So let's take one bond first, because carbon can't bear the shock of losing too many electrons in one go. So negative, positive, negative, positive. What's your next step? Well done. You are going to connect the negative to the positive. So what we will have is the negative alkyl group attaches to the carbon, whereas the electrons of the oxygen are offered to the magnesium. So it's a give and take. O double bond C R O M G X. What's our next step? Yes, of course, acidic hydrolysis. H positive, water. Let's keep things simple. So I'll have over here H and OH. What do we form? Look at this. R, C, double bond O, OH. What is this product? Yes, it's a carboxylic acid. RCOOH plus MgXOH. Basic magnesium halide. So what is happening is ultimately you are just adding an alkyl and a hydrogen atom to the carbon dioxide molecule to give us a carboxylic acid. To put things simply, right? So what's the next thing we are going to do? Yes, of course, we are going to give you an equation to write. So C2H5MgBr reacted with carbon dioxide. Form the products. Tell me what will be the products of the reaction after acidic hydrolysis. Okay, so how many of you got it right? It's C2H5COOH. What is this product? Let's expand it so that we don't go wrong in naming it. So we will have CH3, CH2, COOH. Oh, it's a pretty simple product, right? CH3, CH2 comes here, C double bond O, OH. Remember, see, it's not CH2, CH3. It's the other way around. You have to remember about the tetravalency of carbon. So what is it? 1, 2, 3 carbon atoms. So propane, saturated, so ane. And the functional group is COOH. So it's a carboxylic acid. So the name of this product is propanoic acid. That is why we said Grignard's reagent plus carbon dioxide gives us carboxylic acids. Isn't this very easy? The next behavior of Grignard's reagent is with cyanides. So I have the simplest cyanide over here, hydrocyanic acid, HCN or hydrogen cyanide. And the other reaction we are going to talk about is alkyl cyanides, which in turn give us ketones. So let's start with the first reaction. We have HC triple bond N reacting with Grignard's reagent RMgX. What's my first step? Negative, positive. Easy, no brainer, right? Next, we know that nitrogen is more electronegative than carbon. So it pulls the electrons towards itself, and we will have negative and positive ends here as well. Now connect the positive to the negative and negative to the positive. Things become simpler by the formation of the addition product. But do you think this addition product can last like this easily? Magnesium is highly electropositive. It will have a tendency to get detached. Plus I have nitrogen also over here. So things are a little difficult. So what do we have? Hydrolysis. Now I'm not going into the entire specific mechanism, but I'm going to give you some easy way to remember. So nitrogen means I'm going to get ammonia. So HOH, simple, right? Now if you notice, this NH group is again still going to be basic. If this remains as CNH, double bond NH, then again it's going to be, because of the lone pair of electrons, it will still attract more protons. So what do I do is, I write it as H2O. Let's keep things simple rather than making them complicated. Now write down the product RCH double bond O. What product is this? Yes, of course, it's an aldehyde plus ammonia plus MgX and OH. Simple? Your turn now. HC triple bond N reacted with C2H5MgBr. Form the products. Try the reaction yourself. First the addition product, followed by hydrolysis. Now when you are carrying out hydrolysis over here, notice that you needed 2 molecules of water. So let me represent it like this. We needed 2 molecules, HOH and H2O. Okay, don't think that water is breaking in 2 different ways. These are simple ways to remember, because I'm not giving you the mechanism over here. We can't do the mechanism of each and every reaction, and it is not required also at this stage. So form the addition product and form the product. So what happens over here? The C triple bond N changes to C double bond O. One of its valencies is still free, and there it comes in the alkyl from the Grignard's reagent. What product is this? C2H5CHO. Let me expand it and write it. What product would this be? 3 carbon atoms, prop, saturated in functional group aldehyde, so al. This is a vowel, this is a vowel. We dropped one of the vowels. Proper null is our product. Isn't learning easy and simple and fun as well? Okay, so let's learn from here and take up the reaction of Grignard's reagent with alkyl cyanide. So alkyl cyanide means, let me say I've got CH3 over here. Form the product. It's easy. Go ahead, try it. So instead of the hydrogen, you have CH3. What will be your final product then? The side products remain the same. Yes, it's going to be CH3, C double bond OR. So what product is this? Yes, of course, it's a ketone. So notice over here, Grignard's reagent plus HCN gives us aldehydes, whereas Grignard's reagent with alkyl cyanides gives us ketones. Your question, challenge. CH3 C triple bond N reacted with C2H5MgBr. Form the product and name it according to the IUPAC system of nomenclature. I'm waiting for your answers. Write the reaction, write the steps. Yes, if you only see the answers, you won't get enough confidence. So you have over here CH3, C double bond O, spread out the wings, CH2, CH3. It's easier to name it this way. So you notice here that we started with a compound with 2 carbon atoms and we end up with a compound with 1, 2, 3 and 4, wherein 2 of the carbon atoms are coming from the Grignard's reagent. I could have 5 or 6 depending upon the alkyl group taken in the Grignard's reagent. So let's name this compound. This would be butane 2-one. Easy? Now there are quite a few variations of the Grignard's reagent based on the reactions that we have covered so far. So for example, just like carbon dioxide reacts with Grignard's reagent, carbon disulfide can also react. So you can write these reactions on your own if required by your curriculum. I've tried to cover the majority of the reactions required to be studied under Grignard's reagent. What is left? Yes, we need to know how we prepare this such an important reagent known as the Grignard's reagent. The preparation, according to the traditional methods, it's very, very simple. So what do? Is we take the alkyl halide, react it with magnesium ribbon to give us the alkyl magnesium halide. Now it may sound simple, but it's not so, because we have to be very, very careful of the solvents that we are using. We have to ensure that all our apparatus and reagents are completely dry, not even a drop of water. Can you think why? Go back and try to recall your learning about Grignard's reagent, about their behavior. Yes, very correct, because Grignard's reagent, they react with water to give us alkanes, and we don't want that, right? Why do we want that? No, we want our Grignard's reagent to be available to react with other substances as well. So we ensure that all the apparatus and reagents are dry. As solvents, we can use dry ether or tetrahydrofuran, and we reflux the reactants for a long time in order to get the products. Interestingly, the Grignard's reagent are not taken out separately and stored. In fact, they are left in the flask in which they are prepared. And whatever reaction we want to carry out, we just add those reactants to the flask containing the Grignard's reagent dissolved in ether. So if you notice, my ether is serving as a medium for the reaction. It is a solvent for the reactants. At the same time, it keeps the Grignard's reagent cool and calm and satisfied, so that the highly electropositive magnesium does not get excited and want to run around. So what they do is, the ether molecules, they share the lone pair of electrons on oxygen with the electropositive magnesium, helping to stabilize the Grignard's reagent, and this is called stabilizing by solvation. When we talk about the Grignard's reagent, we have to be careful that there are no flames near the Grignard's reagent as the product is very flammable. The order of reactivity. Now this we've already discussed under haloalkanes as well. The order of reactivity is Ri, Rbr, RCl. Interestingly, instead of the alkyl, you could also have an aryl group. So I could have CH3. My R could be CH3, C2H5, even C6H5. We can have any type of an carbon species over here. But the products will depend upon what we have taken as our alkyl halide. To support your journey through organic chemistry, you will find a lot of these flowcharts on the channel, which have been found to be very handy by the students. At least for the past 20 years, I know they have really benefited from it. So go ahead, use them to help you in learning, understanding organic compounds in a simple way. If you feel connected with the channel and are happy with the learning, please continue to share your joy of learning with friends and classmates, and don't forget your encouraging comments and let me know how we have done so far. Please stay happy and healthy as well. See you in the next video.